Hello everyone. Today we are going to start a new topic that is called R and S nomenclature. Now, what is R and nomenclature? Before going to that, I would like to discuss you a little bit about IUPAC nomenclature. Suppose we have a structure like this one. We have this structure and this is our structure. Suppose this is 1, 2, 3. So it is 2-hydroxy propanoic acid. 2-hydroxy propanoic acid. Now in this structure, this is IUPAC nomenclature. Now, if I have to write down the isomer of this one, optical isomerism or the enantiomer of this one, I have discussed these things earlier. The enantiomers are the mirror image of each other. Suppose if we have the mirror image, then we will get the structure like this. This one. Now, what will be the IUPAC nomenclature of this structure? Both these two structures are there, and they have different configuration according to stereoisomerism. But what is the IUPAC nomenclature? IUPAC nomenclature is same. So we cannot distinguish the isomeric property of the molecule, stereoisomeric property of the molecule, by using the IUPAC nomenclature only. Remember this point. We cannot distinguish between them by the IUPAC nomenclature. Okay? So what we have to do, we have to introduce a new type of nomenclature that is called R and S nomenclature. Now what is done? That before writing the name IUPAC nomenclature, this R and S is added just before that. So then we can predict whether the structure is R or whether the structure is S. Okay, or we can also write like this, S2-hydroxy propanoic acid. So this is the idea by which we can distinguish in between the two stereoisomers. The molecule is same one, but they are isomers of each other. So to distinguish between the two isomers, we can add one term, that is R and S, R or S, before the IUPAC nomenclature, and then we can distinguish between them. Now, how to do this IUPAC nomenclature? We are going to discuss about them. Here, the first and foremost thing, the molecule should be written in Fischer projection. Fischer projection you can remember. So the first thing is the molecule should be written in the Fischer projection formula, so that you can do some numbering on that molecule. Suppose if we have a molecule like this. This is one molecule, and here we have to do the IUPAC nomenclature, as well as here we have to do the RS nomenclature, not IUPAC, RS nomenclature. Now this molecule is written in the Fischer projection formula. I have told you that Fischer projection formula in the chiral carbon should be in the middle, and all the bonds should be written in 90-degree angle. So now this is in the Fischer projection. So we have to do one numbering process. What is that numbering process? It depends on the connecting atom. That means this carbon is connected with this carbon, not with this hydrogen. This carbon is also connected with this carbon. Here is the phenyl ring. So this phenyl ring is having one carbon. So this carbon is connected with this carbon. So like that, all are connected with carbons. Sometimes we can have one different type of molecule like this. Suppose here it is CH3, here it is hydrogen, here it is OH, here it is Cl. So here all the connecting atoms are different. Suppose here carbon is connected with carbon, here carbon is connected with hydrogen, here it is oxygen, here it is chlorine. Now what we have to do, second step, is to do numbering. Numbering means the groups that is linked with the carbon, those groups should be numbered according to their atomic number or priority order of the group. So priority order is a series of the priority order of the groups, but you have to do one thing to remember all these things. It is easy. You start numbering with the connecting atom which is having highest atomic number. Suppose in this case we discuss chlorine is the highest atomic number according to all other. If you see, then number 2 will be oxygen, number 3 will be carbon, and number 4 will be hydrogen. Okay. Now see in this case, here all the connecting atoms are carbons. Okay. So when all the connecting atoms are carbons, then we have to go for the second atom. Second atom means here that carbon is connected with hydrogen as well as this connected with carbon. So here second atom is carbon. Here also second atom is carbon. Here also second atom is carbon. Here second atom is carbon. How to do this thing? This is the thing. These are the things that you have to learn in RS nomenclature. So in this case, you first see this is connected with 6 numbers of carbon. This is connected with 2 numbers. This is also connected with 2 numbers. This is also connected with 2 numbers. So 6 numbers of carbons are there. So that is why this one will be given priority order number 1. Next, here this carbon is triple bonded. Here it is double bonded. Here it is single bonded. Now, in this case of numbering, you always remember that triple bonded carbons are always given preference then double bonded, then single bonded. So, systematically we can give the numbering like this, 3, 4. So, we have done the second step, that is the numbering process. Now, in this numbering process, now we have to see the fourth group. This fourth group, here also this is fourth group. Now, fourth group is very much important in case of RS nomenclature. What is that fourth group? The fourth group should be present in the vertical bond. If it is not present in the vertical bond, then we have to change the configuration of the molecule so that it comes to the vertical bond. Suppose if it is present here in place of 3, then what we have to do? We have to make it. We have to take it from this 3 place to this 4 place. Okay, so there are some rules by which we can change the position. So now what is our duty is to first see the fourth number group, and if it is present in the vertical bond, then it is okay. Then it is okay. And now what we have to do? We have to start from 1, and then we have to go to 2, and then we have to go to 3. Now we have to see this rotation. This rotation is from 1 to 2 to 3. It is anti-clockwise. And here it is 1 to 2 to 3. You do not have to go for 4. Just 1 to 2 to 3. 1 to 2 to 3. Here also it is anti-clockwise. So this anti-clockwise means it is an S configuration. When if it is clockwise, then it will be R configuration. So in this way, we just simply do the RNS nomenclature. Okay, so I repeat from the beginning. First we have to see whether the molecule is present in Fischer projection or not. If it is not present in the Fischer projection, I have taught you how to convert it into Fischer projection. So then what we have to do, you have to convert it into Fischer projection. Then you have to go to the chiral carbon, and in that chiral carbon you have to do the numbering process. What are the rules for numbering? Numbering is done by systematically done by observing the connecting atom's atomic number. If the connecting atom's atomic number is high, then it will be given more preference. So here we have done like that. In case of this molecule, connecting atoms are same. Next connecting atom is also same. But here also some other idea is there by which we can do the numbering. Here highest numbers of carbons are there 6. Here it is 2, 2, 2. But here it is triple bonded. Triple bonded are thought like that. It is connected with 3 other carbons like that. So here double bonded, here single bonded. So after doing all this numbering process, then we have to see the fourth group. If it is present in the vertical bond, then we have to, it is okay. If it is present in the vertical bond, then we have to move from 1 to 2 to 3, and then if it is clockwise, it will be R. If it is anti-clockwise, it will be S. Now come to one example where fourth group is not present in the, suppose similar example if we write like this. If we write like this, this is a similar type of example where this is number 1, this is number 2, this is number 3, this is number 4. Now we can see the fourth group is not present in the horizontal bond. Here one very good rule is there. What is that very good rule? If this fourth group is not present in the horizontal bond, that is not present in the vertical bond, then we can move from suppose 1 to 2 to 3. It is anti-clockwise. So the name should be S. If it is anti-clockwise, it should be S. But since this fourth group is not present in the vertical bond, so what we can do? We can do the nomenclature, or we can write down the alternate nomenclature, that is R. We can directly write like this. This fourth group is not present in the vertical bond, but according to this nomenclature system we are getting it S, but it will be R because this fourth group is present in horizontal bond. We do not have to move it to the vertical. Okay, but it is a simplified way by which we can do this R and S nomenclature. Next, I hope you have understood this one. This is done only in case of the molecules where we can write down the carbon like this in this Fischer projection. Some other type of molecules are also there where chiral centers are there. Suppose if we have a cyclic molecule, a cyclohexane where one chlorine is there, here one suppose CH3 is there. Now this is given that this tarmac carbon is a chiral carbon because this carbon is connected with 4 different groups. Here one hydrogen will also be there, but hydrogen is not written. Suppose I have written the hydrogen. Now you have to find out the configuration of this carbon, this tarmac carbon, that is the chiral carbon, in case of these cyclic molecules. Now in case of the cyclic molecules, we have to do the numbering process in a similar way. But one condition should be there, that at least one group should be given above the plane or below the plane. That means in this molecule it is given that this carbon, this chlorine is above the plane, this hydrogen is below the plane. But in this carbon we cannot do the RNS nomenclature. Why? Because this is not given that this is this carbon is present, this methyl group is present on the plane. It is not above or it is not below. So when anything is not given above